Hello everyone. Today we are going to present speed control of DC shunt motor, and this is presented by Nikhil Prakash Shendge, Yash Ghanasham Kulkarni, Suraj Bajrao Chavan, and Prathamesh Kumar Madi. Myself, Yash Ghanasham Kulkarni, roll number 2156009, and I present the first point. What is DC shunt motor? A shunt motor is direct current motor whose two windings are in parallel with same voltage across each. A shunt motor is designed to run at practically constant speed. Field winding and armature are connected in parallel. So basically the working principle of DC shunt motor, when we supply DC current to DC shunt motor, it converts electrical power into mechanical power. So this is the image of DC shunt motor and parts of DC shunt motor. The next point is speed equation of DC shunt motor. So this is the equation of motor. V is equal to EB plus IARA, where V is the supplied voltage, EB is the back EMF, and IA is the armature current, and RA is the armature resistance. And the next equation is EMF equation. In this equation, EB is equal to P phi Zn divided by 60A, where in this equation, where P is equal to number of poles, A is the constant value, Z is the number of conductors, and N is the speed of motor. So this equation of EMF equation, the value of EB is substituting in the first equation, that is the equation of motor. Then we get V is equal to P phi Zn divided by 60A plus IARA, or this is V minus IARA is equal to P phi Zn divided by 60A. That is the N is equal to P phi upon 60A into V minus IARA divided by phi. So in this equation, phi is equal to flux, and the above equation can be also written as N is equal to K into V minus IARA divided by phi, where K is the constant and the value of K is P phi upon 60A. Further point will explain by Nikhil Prakash Shendge.
Hello, good morning everyone. My name is Nikhil Prakash Shendge. Here are some of the methods of a speed control of a DC motor. The first method of a speed control is armature resistance control. Second method is the field flux control method. Third one is the armature terminal voltage control method. I am here to present the first method of a speed control of a DC motor. So for controlling the speed of a DC motor, we need to decrease the voltage, which will cause for the reduction into the speed of a DC motor, which we can say that the speed is related with the current and the resistance into the circuit. By definition, the variation of a resistance into the armature circuit is called as an armature resistance control method. In this method, the variable series resistance RE is put into the armature circuit, and in this figure it shows the method of a connection for the DC shunt motor. In this method, the field is directly connected across of the supply, and therefore the flux phi is not affected by the variation of an RE. When we vary the resistance RE, it will affect the armature current and the armature resistance, which will cause for the voltage drop across of the resistance, and the speed will be reduced. So that's why the variable resistance RE, we can control the speed of a DC motor by below its rated speed. Drawbacks of an armature resistance control. The first drawback is the large amount of power is lost into the external resistance, and second is that this method gives the speed below the normal values. Third is for the specified value of an R, the speed reduction is not a constant, it varies with the motor load. So next further point will be explained by the Prathamesh Madi.
Myself Prathamesh Kumar Madi, roll number 2156014. I present flux control method. The speed of DC motor is inversely proportional to the flux per pole. This by decreasing the flux, speed can be increased and vice. To control the flux, a rheostat is added in series with the field winding. Adding more resistance in series will the field winding is increase the speed as the decrease the flux. In shunt motor, as the field current is reversely very small, as to R loss in small. Next point is the drawbacks of the flux control method. only speed higher than the normal speed can be obtained since the total field circuit resistance cannot be reduced. There is limit to the maximum speed obtained by the speed method. In this, because it is the flux is the too much weekend communication because poors. The next point present the Suraj.
Hello everyone, myself Suraj Bajrao Chavan, roll number 2156013. My point is armature voltage control. This system is used where very sensitive speed control of motor is required. For example, electrical excavators, elevators, etc. This system is also known as Ward-Leonard control system. M2 is the motor to which speed control is required, and the M1 may be any AC motor or DC motor with constant speed. G is the generator directly coupled to M1 motor, and in this method the output from generated G is fed to the armature of the motor M2 whose speed is to be controlled. The output voltage of generator G can be varied from 0 to its maximum value by means of its field regulator, and hence the armature voltage of the motor M2 is varied very smoothly. When we control the voltage of a M1 motor, then generator speed is controlled, and this generated output is given to the M2 motor. And when we control the voltage of M1 motor, then current rotor speed of the M1 motor is controlled, and from which generated output is controlled, and M2 motor is speed is controlled. The next point, drawbacks of armature voltage control. The initial cost of the system is high as there is a motor generator set installed of the same rating as that of the main DC motor. Larger size and weight requires large floor area. Costly foundation, maintenance of the system is frequent, higher losses and lower efficiency. The conclusion of this presentation, we understood different methods of speed control of DC motor. In armature resistance control, large amount of power is lost in external resistance. In flux control method, to control flux rheostat is added in series with field winding, and the armature voltage control method is used where very sensitive speed control of the motor is required. Thank you.